आज ज़्यादा लेट हो गई क्लास. So recording started. So this is what we have discussed in the last class. So let's just see the summary. So flavor of Linux. So it's just Red Hat or something else, Red Hat, Ubuntu, or other flavors of Linux. For banking sector, there is another Linux. For education sector, it is another Linux. For mobile phone, the Linux is different. It just depends on the use case. So everyone is having different flavor of Linux, but the kernel is same for every use case, right? Then architecture consists of two parts, that is user space and kernel space. So in kernel space, the labeling the file system and all that is connected in the kernel space, and the rest of the things is present in the user space, which the user designs to run that. So kernel is like pizza base, and above that all the toppings that we add is in user base. So difference between Windows and Linux, so that we discussed in the previous class. So it was just, so one is microkernel and another is monolithic kernel. So that is the difference between that. And so we learned about what is kernel and what is the components of kernel. Then features. So one of the features, the most important feature of Linux was hot swapping. Hot swapping allows us to add or remove apps without restarting the system, because all the things are loaded in kernel, and kernel reloads and refreshes them automatically. The naming of kernel, so 2.1, 2.3, 2.4, so how they are named, that was studied in this case. The stable one was having 2 point even number. So 2.3 is unstable version, 2.4 is stable version, 2.5 is again unstable version, then 2.6 is a stable version again. Then we learned about threads and processes. So processes are the major thing. That is, if we are running two calculators, then both of them is called processes, and the addition and subtraction thing that is going inside a process is known as threads. So that is threads, and every process has some specific threads. Then we talked about process states. So process states is, first the process comes into the execution, then it becomes ready. Then after being ready, it gets executed. Then if the user exits it, it gets exited. If the user restarts it, then it goes to the waiting state and restarts again. So this was that. So new process was there, then it goes to the ready state. Ready state, that means it is ready to be executed. So once it is executed, then it is in executing state, that is running. And after running it, there's if someone pauses it, then it again goes to ready state. If someone just closes it for some time, then it goes to waiting state and again goes to ready state, restarts that process. If someone just exited that code or process, then it goes to terminated process. So that was the summary of last class. Now we have to study about memory architecture. So basically the system is having CPU register. So CPU, a square chip. So a square chip that is present in the system is known as CPU. So this square chip is known as CPU, and it is having a lot of pins that are connected to the motherboard. So this CPU is responsible for everything that is possible in the system. CPU is the major component of the system. It does all the calculation and all the stuff. So just for a fact, initially the size of CPU was bigger because the transistor size was bigger. Then the advancement in technology made the size smaller. So currently we were using 14 nanometer chips, and then 14 nanometer was like taken over by 7 nanometer chip, which is the latest in the architecture of CPU. So if you purchase a new system, new computer, it will be definitely having 7 nanometer CPU. So 7 nanometer chip is CPU chip, which is the latest in the market, and it is having a lot of transistor present in a very small area. Like making the CPU small is having the benefits of, like, if the CPU is very small, then it will get heated slowly, and if it get heated slowly, then it will work good for a longer time period. And that's why everyone is trying to minimize the CPU size. So basically, this is a disk of silicon that is used for creating CPUs. So in this circular disk, we have to cut the CPUs. So we have to cut the CPU. So basically, if the CPU is that much big, that let's suppose this is 14 nanometer CPU, then we have to waste some of the CPU because this one will not be possible for us. So we have to limit the number of CPUs in that process. So less CPU is being cut from this chip. And when we try to reduce the size of CPU, let's make it 7 nanometer, like this much. A lot of CPUs can be like brought up from this, made up from this silicon disk. So that's why every company is trying to reduce the size of their CPU so that wastage could be minimum, and that area should be less. So basically, that is the thing that every company is trying to reach for. And definitely, if the size of chip is if the size of chip is like 7 nanometer, then the thing that the company is selling, like Intel i7, Intel i5, so the chips that the company is selling, the price will also get reduced to a very high cost. So yeah, that's why every company wants to make the CPU size small. Then after the CPU register, there is cache. So cache level 1, cache level 2. Then finally the RAM comes, and RAM is physical RAM and virtual memory, right? So physical RAM is the RAM that you just put in your computer, like 2 GB, 4 GB. But virtual memory is something that is not a RAM, but your hard disk space is used as RAM in this case. So if you are having a 4 GB RAM, that 4 GB hard disk space is used as RAM. So that total CPU, so total RAM in your computer will be 8 GB, 4 GB physical RAM and 4 GB virtual memory. That is your hard disk space. Okay. Then storage devices. So storage devices, ROM, that is used for BIOS storing, the blue screen that you observe while loading the screen, loading the operating system. Then removable drives. So these are the drives that you attach. Then internet storage. These are the server storage or some cloud storage that you use. Then finally is hard disk drive. So these are the four types of storage devices. Then input sources. So sources are keyboard, mouse, removable media, scanner, media, camera, mic, and remote source and other sources. So basically, the cost of things increases from down to top. Speed, but space increases in this way, and also speed or cost. We can say that. So speed and cost. So the CPU register is the costliest item in the whole system because, just for example, the CPU register or CPU will be having a cost of around 30,000 if you are buying a best one CPU. Else generally you will get something in 14,000 also. So it's cheap, but not that much cheap. So it's 14,000 rupees for just a square piece of uh, aluminium. So you are giving 14,000 for that. Then for RAM, the cost is around 6,000 for a RAM. Then storage devices, ROM, removable drive. So you can definitely buy removable drive for at least 3,000 maximum, for 3,000 for 1 TB, or maybe more, like less than that, and 3,000 for a hard disk drive. Then keyboard mouse is 1,000, 2,000. That's enough for these. So just you can see that CPU is 14 times costlier than mouse or keyboard. So you can buy 14 keyboard mouse if you are not buying the CPU. Okay, right. So there is another question: how Linux runs on Raspberry Pi but not Windows? Like you can see that in all the devices, like even on our phone, Raspberry Pi is running perfectly fine on the CPU, on the Linux, but not on Windows. And also on our phones, we are not using Windows. You know about that, like Lumia and other stuffs that Microsoft presented. No one was trying to buy those because it was really slow and it was laggy. And after like a lot of time, they just went out from the market because no one was using that. But Android is still in the market, and everyone likes to purchase Android. And there are a lot of phones that crossed around 1 lakhs 2 lakhs just for Android. So yeah, Android, what is the benefit of using Android? So Linux physical memory management system deals with allocating and freeing pages, group of faces, and small block of memory. So Linux physical memory management system is so good that if you are not using any app or you not using something else, then it just cleans that space and give it to some other app. So like if you are running PUBG or some game in your phone, then automatically it just closes all the apps running previously in the background and just makes the best use of that PUBG or the game that you are running on. Right. So that is the only benefit of Linux. So, and it is additional mechanism for handling virtual memory and memory mapped into the address space of running processes. So like if you are running a big program, like let's just suppose if you are running an app that is having the capture of your phone camera and it is taking selfies, it is also playing songs, it is also doing some other stuff like operating the flashlight. So three things are running in your app. First is the camera is running, the flashlight is running, and thirdly, the song is being played. So all three things require memory at different level. So Linux is having additional mechanisms for handling different processes in different areas. So every area of your system of your phone is running different process without any issue. But if you are running a different thing without additional mechanism, so if we just remove this additional mechanism, so either one of these three things will be running on your system. So either you will be running a song or a camera or a flashlight. So if you want to run all three of these, you will not be able to do that. Okay. Then finally, splitting the memory in buddy heap. So that is a thing of Linux. So what it does is, if you have a 16 KB program or 16 KB memory, then it gets segmented into 8 KB and 8 KB. Then again, the 8 KB is distributed into 4 KB memory parts. What that means is, if your system is using something like a project requires a very less RAM. Like if you are running just flashlight, it is taking very small memory. Then this 4 KB of memory will be allocated to that. And if your system is running a lot more heavier thing like taking the images and using camera, then it will give 8 KB of that. In another case, like in another OS, sometimes it may happen that it will give the whole 16 KB to just flashlight only. So what that means is, all the 16 KB memory of your phone or 16 KB memory available in your system will be given to one task only, and you cannot run multiple tasks in that part. Okay. So now allocation and delocation. It is the final slides that will be covering the architecture of Linux. Then we will be moving completely to scripts because we now know all the architecture and all the things that are in the Linux thing. So allocation and delocation. So allocation means allocating a memory to a particular task. Delocation means when a task is completed, just take the memory back from the system. So what that means is, it will take the memory when from the process which is not running, it will free the memory. Allocation means it will give the memory from the heap to something else. So to the same process. Okay. So this buddy heap algorithm will be used for further purposes. So what is this is, The page allocator allocates and frees. Where is the cursor? Okay. The page allocator allocates and frees all the physical pages. It can allocate ranges of physical contiguous pages on request. So physical contiguous pages on request. So if your program is requiring a lot of memory, it will just do a simple thing. It will take all the things, all the memory group, and it will combine the whole memory group and give it to your program. So if your program is requiring 16 KB of memory, it will combine all the things and will give the whole heap to that program if it is requested. And if it wants smaller part or smaller memory of RAM, so what it will do is it will split the whole memory into the part which is required by our system. Okay, so the allocator uses a buddy heap algorithm to keep track of available physical pages. Each allocatable memory region is paired with adjacent partners. So whenever two allocated partner regions of both are freed up, they are combined to form a larger region. So that is what I just told you in the previous thing. Yeah. So that is what I just told you about that. So buddy heap. So if the program is requiring larger memory of RAM, so the two allocated free regions will be combined to create a bigger region. But if the small memory is requested, then it will free the region and can divide that into subparts. Okay. So if the small memory request cannot be satisfied by allocating existing small free region, then the larger free region will be subdivided into two partners to satisfy the request. Right. So it is like clear from the memory aspect that what Linux does. So if some process requires a larger memory part, then it will combine all the free memories to create a bigger memory and will give it to that program. But if we are requiring a small memory part, then it will break the larger part into multiple regions to give the to give it to the last part. So what it will do is it will break the larger part into multiple regions and will give us 8 KB of memory so that we can run our program. But if we are running a very small program, then it will split the 16 into two, and this one is for other purposes. This is free, and then this one will be used, but the person needs more less memory for that, so the system will free this also, and this will be used for flash, and another 4 KB will be free again. So that is the allocation and delocation for the Linux. So basically memory allocation in Linux occur either, so there are two ways of allocating memory in Linux kernel. So first one is statically, and second is dynamically. So dynamically means the thing that we have studied in this upper part. So dynamically means it will automatically figure out which project will require. Uh, okay. Okay, so the session is recorded. You can see it later. So memory allocation is in two parts, statically and dynamically. So statically uh, basically means the driver will reserve a contiguous area of memory during the system boot time. So statically means the program that you are running will have a spatial reserve of memory. So in that spatial reserve of memory, the program will be having that. So if you want to watch a movie, then the system will definitely preserve some memory for that. So 20 KB or 30 KB memory is saved for your movie, and rest all is given for dynamically allocation. So dynamically allocation is automatically changing the memory requirement or memory size based on the requirements. Okay, so that is the important thing in allocation and delocation of Linux. The next thing is address space. So previously we have talked about memory and memory region. Then why the memory region, or where the memory is stored in some area? So that is to be learned in this. So that is address space. So in address space, the virtual machine, the VM system maintains the address space visible to each process. So all the processes will be knowing the free space available. So if some process require a new space, then it can get from the address space, right? Yeah, so it creates spaces of virtual memory on demand and manages the loading of those spaces from disk or swapping back out to disk as required. And another thing is the VM manager maintains two separate views of a process address space. So a logical view and an address space view and physical view. Okay. Okay. So let's just okay. So address space, like let's just go to that once more. So this is allocation and delocation. So if the memory is allocated, if the memory is free, or if the memory is occupied by some program, like if you, let's just suppose you are having a 8 GB RAM in your phone, and out of 8 GB RAM, 4 GB is used by PUBG, and rest all is free, right? So you will be using 1 GB for music. So let's just write it here. So you are having 8 GB of RAM, 8 GB of RAM in your phone. So out of that, 4 GB is used by your game, and rest all is free. So there should be some place where the records need to be kept. Like this much RAM is free and this RAM is available. So if you just run a music player with parallelly to your game, then it should be visible to that 4 GB RAM is free. So the space where everything is written, where everything is present, the RAM free, the RAM used, that is called address space. Okay, so the VM system maintains the address space that is visible to each process. That is an important thing because the address space is visible for each process. So music, this address space is visible. Music knows that 4 GB is used by game and 4 GB is stored free for me. Then I can use the free space, right? And like you have realized that if you run music with the whole memory occupied, like so if you have 2 GB of space, I don't know what it so if you have 2 GB of space and you want to run music on it, but you are using this much for PDF, then you want to run music here, but music will require 2 GB of space. You are not closing this PDF because you want to study and you want to listen the music also. So what the system will do, it will slow down. First thing is it will definitely slow down. So what happens when the system just slow down? It tries to close the PDF. It tries to close the PDF and reduces the size to 1 GB. So that PDF will be settled in this part, so that music will get this part, else music will be having just 200 MB of space. So that's why you have realized that in your previous or old phones, when you run a small application and you run a bigger application on that again, the whole phone starts to lag out, and it gets into a space in which it is not usable anymore. So it just gets stuck and everything just pauses, and you are not able to do anything in that system. So that is due to this thing, because we try to run the application which is requiring more RAM, more memory than the system is currently having that. So the music app, the address space is visible to the music app, but it tries to reduce the size of PDF so that music can be added in that. And in that case, the whole system gets slowed down and just becomes laggy. So that is address space. Okay. So the VM system maintains the address space that is visible to each process. It creates pages of virtual memory on demand and manages the loading of those pages from disk or swapping back out to disk is required. So it can create more space, or if space is enough and not required, then it just gives the space back to the disk. Okay, so VM manager maintains two separate views of process address space. So it maintains two separate views of that space. So first one is a logical view and another one is a physical view. So logical view is describing the instruction concerning to the layout of address space. The address space consists of set of non-overlapping regions, each representing a continuous page-aligned subset of address space. So logical space and physical space, that is enough to be learned for scripting. No need to get into the depth of that. Just we have to know about that address space, how it how it works, and how it stores and writes the memory used by each program. And and one more thing requires to be learned from this thing, that is, if we are running an app that is taking that much of space and we create or start another app, then what will happen? So then we have to tell that if it is not having enough space to run, then it will try to squeeze the other running process so that it can be fitted in that memory. So that is the process that we have to explain if someone asks what happens if we try to run another program when already a running process is there in the system. So we have to tell that about the address space. So address space knows about everything, all the memory, all the space saved or used by all the processes. So that is the thing. Okay. Okay. So how files are stored? That is an important thing that we have to know, because files are nothing, just a binary value. So 0 and 1, 0, 1, 0, 1. That is the only thing that is stored in files. So how files are stored? So a file system is the method and data structure that an operating system uses to keep track of files on a disk or a partition. That is the way files are organized on the disk. So file system file system manages the files which are stored and where they are stored. So it depends on file system where the files are stored. Okay, so a file is stored in string of bytes. What that means is, every file that we create, a song, a video, a image, everything is just a string of bytes. So files are organized in a directory. So basically what a directory is nothing but a folder. So folder are used for organizing the files, because if we are trying to maintain an hierarchy, so A, B, C, then A is having three folders: small a, small b, small c. Then B is having C and D, CC and DD. So these are the directories and these are the final files. So final files are having an extension of, let's suppose, txt. So these are the files. Okay, so files are stored in a directory, and directory is the name of folder, and file information, that is size, owner, access permission, etc., are stored in separate data structure called inode. Okay, so most of the files that we run are not accessible by the user. So why that happens? If we try to open the files of like in Windows, we try to run the files of C drive, system32, and program files, it says that you are not allowed to access this file. You cannot delete this file. You cannot add anything in this file. So that is just due to access permission. So they are not giving access to the person. So to avoid the system being crashed. So if a layman person just goes into that folder and deletes the Windows file that is having all the records, and it just get deleted unknowingly, the whole system will get blocked. So the system will come into a unusable space, like unusable shape. So we can't use that system again. So that's why access permission needs to be required, and every file has an access permission. So if you are running a song and you don't want anyone to delete that song ever, you can just put a permission on that. No one can delete this song without my password, and my password is this. So all these things are stored in inode. So that is an important thing. Inode is where the file information is stored. File is stored in directory, but file information is stored in inode. Okay, so superblock is a data structure containing information about a file system. So a file system is the thing that an operating system uses to keep tracks of files, and superblock is having access to that file system. So superblock is storing the information about that file system. Okay, so this one was the slide. You can view that later also, because it will be recorded and the recording will be shared. Okay, so that is just a file system that we don't need to study much. It's just because the information exists in kernel memory only, and during the period when a file process has the file open. So when we open a file, when we open a text file, when we open a music file, the information goes into the kernel memory, and we close the file, it automatically gets closed. So a file object stores the information about the interaction between open file and process. So what do we mean by open file and process? So open file means an mp3 file, and process means music player. So that is the thing about file system. So file object is storing the interaction between the file and the process. So this information exists till when the process is open, when the file is open. As soon as we close the file, everything gets deleted, everything gets closed. So when we just save the file and close the word or close the music player or music editor, the file gets saved and we are ready to open the new file. So that is file system. Then few slides are remaining about this architecture. Then file systems are checked at boot up, that is while loading the kernel. In maintaining consistency by FSCK and E to FSCK, lost and found thing are checked by file maintenance, and then these are the file systems for maintenance. So tune to FS, dump to FS, and debug FS. So debug FS is debugging for the file system. That dump to FS is dumping something to the file system. Then tune to FS is checking all the errors that are present in the file system. Okay. Yeah, that's now the driver, device driver. So if you just purchase a new mouse, if you just purchase a new mouse or a keyboard, and you want to run or you want to use it with your PC, so basically you are just pressing a button. How should the computer know that it is a power button or a volume button or just a click? So that care is given by device driver. So device driver take a special role in Linux kernel. They are distinct black boxes that make a particular piece of hardware respond to well-defined internal programming interface. They hide completely the details of how the device works. So basically, if you are watching a movie, then automatically the system gets the detail of your screen and will show the image to your complete screen. So that is the driver, the device driver that is working on it. If you are listening to an earphone, then automatically the sound that is coming from your earphone is very low, and the sound difference between your phone speaker and earphones is different. So that is defined by the device driver. And if you are using a mouse, you are using a trackpad, then which button you are using, which button should do what thing, that is all written in the device driver. So if some driver is missing for some object, it will definitely not run. It will be no use for that system, right? So that is the thing by about driver, device driver. So there are three type of drivers: character device driver, block device driver, and network device driver. So you can note that if you want. So character, block, and network. These three types of drivers are present in the device driver. If you want to know the okay, so if you want to write the definition of this, then you can write this. So they are the distinct black boxes that make a particular piece of hardware respond to well-defined internal programming interface. They hide completely the details of how the device works. Right. Okay. So final thing is network stack. Now you have your computer setup. You have mouse, keyboard present in your system. The devices are loaded. You have now caps lock working fine, numlock working fine, and enter key, escape key. All these functions are working fine. After installing your drivers, the mouse scroll wheel is working fine. It is not clicking anything. The left and right clicks are not working as enter key or space bar key. It is working perfectly as left and right keys in your mouse. The screen is showing the font which is your system is showing. It is not showing any random black screen or something else. So your drivers is completely set up. Your system memory is also set up in the first thing that we did. We have RAM, then CPU, then all that thing. So now the final thing is required, that is networking. So we need to connect our system to the internet. So that is where network stack comes. So network stack by design follows a layer structure modeled after the protocol itself. So the protocols are used in network stack that make the whole networking possible. So yeah, internet protocol is the core network layer protocol that sits below the transport protocol. So the first layer is internet protocol, then So above the internet protocol, there is transport protocol. So and then above TCP is the sockets layer, which is invoked through SCI. So SCI. SCI full form is Serial Communication Interface. Okay. So this is Serial Communication Interface. Then socket layer is the standard API to the networking subsystem. It provides user interface to variety of network protocol from raw frames access to IP protocol data units. So this is used. So basically what it does is provides user interface to variety of networking protocol. Which one? Socket layer. Then from raw frame access to IP protocol datasets and up to TCP, the user datagram protocol. So TCP and UDP is managed by socket layer. The socket layer provides a standardized way to manage connections and move data between endpoints. So socket is the thing that is enabling us to move data from one point to the another point. So if we write this, then we have IP first, then above IP we are having TCP, then above TCP we have sockets, then above sockets we are accessing the data with SCI, and the full form for SCI is Serial Communication Interface. That is Serial Communication Interface. So that is the thing. So socket is the most important part of that, and below socket TCP is there, and more below that internet protocol is there. Okay, so architecture dependent code. Just I have told you about x86, x64. x86 is generally like 32-bit. x86 is less than 84. x86 is less than x64 because it is 32-bit thing, it is 64-bit thing. So I have already told you about giving the calculator example of 64 and 32-bit. So architecture dependent code. So whatever we are creating for the system is dependent on the architecture. Like if we are creating a calculator app, we create different for different system. So if you are creating for a higher end system, we will be definitely using the 64-bit architecture. Okay. So while much of Linux is independent of the architecture on which it runs, like as I told you earlier, the 32-bit cannot run the 64 codes, but 64 can run 32 and 64 both. So that is the dependency on Linux. So yeah, still there are elements that must consider the architecture for normal operation and efficiency. Linux architecture subdirectory defines the architecture dependent portion of kernel source. We will see this directory when we are doing practical. So portion of the kernel source containing the number of subdirectories that are specific to the architecture. For a typical desktop, i386 directory is used. So i386, so 86 is again this one, same directory is used. Each architecture subdirectory contains a number of other subdirectories that focus on particular aspect of the kernel. And what are the aspects? Boot, kernel, memory management, and others. So booting is dependent by architecture, kernel is dependent, and memories. Because you can directly know about this is 32 is having this much of code and 64 is having this much of number. So this one will require higher memory, this one will require lower memory, and based on that 4 GB greater than 4 GB is used in 64-bit, and less than 4 GB is preferred for 32-bit system. If you have more RAM than 4 GB, then we will definitely go for 64 GB. Okay, then the final thing is Linux commands that we will be learning in the next class. So that's it for this, because we have covered all the things that are present in a Linux system, and we just read about starting from the initial thing. So starting from the CPU, and we ended till the system. So from CPU we started, then we added RAM to it, hard disk, keyboard, mouse, and other thing. Then we added drivers for that. Then we have learned how the drivers are added in a system. Then after adding the drivers, we are just running that drivers and also maintaining the uh, permissions for all the codes. So which thing should be accessed by the person, or which thing should not be accessed by the person. And one thing I would like to mention, that we have completed this architecture, and now we will be learning the commands. So shell script and shell commands. So the best thing would be just take all the lectures again, just watch all the lectures again. All the videos and recordings are saved and shared with you, so just watch them again and create notes for that. If uh, if you don't create notes for them, or if you don't revise it, uh, it will be very difficult for you to learn all these commands till the interview. You will definitely forget everything that we have learned till now, and in shell we will be using all those to implement all the things. So it is really important to do all the basic parts from the starting of the presentation till the end, till here. Everything should be completed. Yeah, okay. That's